Hello and welcome. My name is Monica, and I am a developer advocate here at Starburst. I hope that you can see me and hear me. I am so excited today to be delivering Starburst 101 with you. This is going to be an awesome session where hopefully you'll get a little bit hands-on. We'll be able to sort of, run through a little bit about what Starburst is, learn a little bit about Trino, and then we'll be able to, talk about any questions you have, answer anything that comes up as we're going throughout the lab. I would like to do a couple of housekeeping announcements. I'm just going to wait a minute before so we can see if there's any stragglers that want to join us. But really, what I want to say is thank you so much for being here today. As we're going through this lab, if you have any questions, please go ahead and enter them in the chat. I have some awesome friends willing to help me with all of those questions. And I will be here to periodically check the chat and do what I can while we're working throughout the lab. Now, this is a hands-on lab today. So if you're interested and you'd want to work alongside me as we go through the lab, we have that ability. You just need to click on the Docs tab and you will be able to get a lab guide. I also emailed the lab guide to anyone who has signed up before yesterday. So that should be in your email as well. If you have any questions here, just go ahead and look at the lab guide. So I'm going to just pop over and make sure that I can share my screen properly because it looks like we're not seeing it. So let me go ahead and say share. And I think you're able to see now, which is fantastic. And let me click on all of it. Perfect. I'm just going to make this big. And if you have any questions throughout, like I said, any questions throughout the entire lab, just go ahead and ask away. Okay, so let's get to the housekeeping items so then we can start rolling with the lab. The first housekeeping item is, of course, hands-on lab. So that means that if you want to do the hands-on portion with us, go ahead and sign up for Galaxy now while I'm talking about all of the boring stuff on the slide. So while we go through these slides, we're going to do a little bit of an intro with Starburst and Trino. Go ahead and sign up for Galaxy if you have not yet done so. That is, the steps to sign up for Starburst Galaxy are in the Docs tab, and they are on page 3 through 7. In that, it will walk you through exactly how to sign up and all of the information that you need. If you're like, let's just watch today and I'll do the lab later, that's totally fine. You will have until September 4th with these specific credentials so that you're able to go back and rework the lab at your own pace. If you want to watch, if you want to half listen, if you're doing other things, that's totally okay. I know it's a busy time for everyone. Go ahead. Don't worry about it. You can work the lab later at your more convenience. We'll send out the lab recording, the slides, and the guide later after this webinar is concluded. So that is just a little bit of the information for you. I also have the lab gist, just a public gist I made essentially for all of the queries in case you're getting tired of copying and pasting over from the lab guide. So that's just, another ease of use thing in case you want to utilize that. Okay, so that should be all of the reminders. I have one more really, really, really exciting announcement. We are scheduled to have our annual conference, our Data Nova event, virtually on October 23rd and 24th. It is a global free event. It is going to be fantastic. I am involved in a lot of the sessions, helping with building the curriculum. So we've got people like Ben Stansel, Michelle Yee, Tobias Macy, our old senior vice president who's now building an ice house at a different company, Ken Pickering. We have a ton of different things that we can help you with and learn throughout Data Nova, and that is on October 23rd and 24th. And Anna is going to put a registration link for Data Nova in the chat so that you'll have any interest you want. There's also a bunch of sessions. Justin Borgman, our CEO, will be doing a session. Tobias, our chief product officer, will also be doing a session. So you get a lot of information from a lot of industry leaders across the entire event. As far as this specific workshop. We don't have any certificates or badges. This is really just an intro to get you excited. But if you want to look into any Starburst certifications, go ahead and send me an email. I have all the information for you to get you all of that you need. Okay, so I think that's all of the announcements. So I think we are ready to jump in and we will get started with our Starburst 101 today. So, what we're going to do, like I mentioned, we're going to start with sort of an introduction to Trino and Starburst. We're going to get a little bit of the history, a little bit about what Starburst is, why it matters, how Trino came into the realm. And then we're also going to get hands on with Starburst Galaxy. And so, the reason we're going to use Starburst Galaxy is because it is the easiest and fastest way to get up and running with Trino. So a lot of the concepts that we're going to apply talking about Trino, talking about Starburst, we're using Galaxy because it's super easy. It lets you get hands-on, get a little bit of a touch with the product. If you want to dive deeper, that's again, go ahead and send me an email. We can send you some more labs that you can utilize on Starburst Galaxy, or we can start talking to you about other options that you may have. So let's jump in. The first thing I want to talk about is specifically Trino and Starburst and how Trino came to be. So, really, we have a little bit of a history of Trino, some before lessons of how did Trino even get developed. So, around the early 2000s, we really saw this data generation boom where we had a lot of trouble querying large volumes of data, and it became difficult and time consuming to do so. So the internet age rose up. We saw data of all different types and all different things that we previously really had thought unimaginable. And it became extremely difficult to really get any insight out of that data or even process it because of that data, the volume and the velocity and the variety that it had. So in 2005, Roger Magoulas actually referred to this large data set as big data. And so that's really taken off as like this big data name, thinking the petabyte scale, even greater, basically trying to query data at this volume we've previously thought unimaginable. And in 2006, Hadoop was actually created and designed to meet that large scale need of the big data, right? So a lot of people are still using Hadoop for this purpose, using Hadoop to actually process this big data. But there actually is, more importantly, they needed a better way. Hadoop was not solving all of the problems for them, and it was really struggling specifically at Facebook where Trino was created. So, if we look at 2008, we were still having these difficult and time consuming processes, even with Hadoop. Essentially, Facebook was created Hive to query this terabytes and petabytes of data in Hadoop using a SQL-like interface. So, what happened is they had these Hadoop, this had this Hadoop environment, but it was gate kept as to only certain people could really query the data that was living in this Hadoop environment. They knew they had a lot of people who wanted to use something that was alike SQL, something around SQL, SQL inspired, very SQL-esque. And so that's why they created Hive. And it was a great idea, SQL on Hadoop, a great thing that they were trying to bring to the data analysts, data consumers, data engineers, anyone who was they were trying to democratize data essentially. But they still had some issues where the data consumers were actually really limited by the specific number of queries they could run. They often ran fewer than 10 in a day, and that we're going to run 10 in an hour. So, you can see how that would really affect their job, their ability to query the data, their ability to get that information. We also know that data scientists were trying to query these massive object stores, and the performance was still too slow. So, obviously limited by the number of queries they could run, but then also just performance was really, really slow. And so they were really struggling with this issue at Facebook around 2008, 2010. And that's where Trino comes in. So in 2012, Trino, which is formerly known as Presto, was created by Martine, Dane, David, and Eric at Facebook. And the whole goal of creating Trino was to basically harness that power of distributed computing. So separate compute from storage, all the good things that Hive brought us, right? You can see the iteration in the threads from Hadoop being that petabyte scale, trying to increase performance. Hive then doing the SQL-like interface, but still being too slow. And then Trino building on that as a replacement for Hive, trying to be super fast and performant at that petabyte scale. And the best part about Trino is that it's anti-SQL based. So that means you can have SQL on anything. So essentially taking that thread of all of the things that had worked well and people had enjoyed, and you can see that they have built Trino again for that Hive replacement initially. Now, what's really cool is Trino has the SPI, the service provider interface, which lets you actually build connectors and communicate with this standard ANSI SQL across multiple different data sources. And that standardization makes it so that you can actually federate your data from not just Hive, but you can also federate with MySQL, Cassandra, whatever database it may be. I'm sure that Trino probably has a connector for it or it's in development. And so basically, that's grown from just the standard, oh, it's going to be just a query engine for Hive to Trino then grew into this federation engine. And so really the whole basis of Trino's origin was for this ad hoc analytics engine. But really by I want to say by Martine did a presentation on it. It was also widely adopted as the engine of choice for batch jobs at Facebook too within a couple of years. So really just a full multi-purpose engine, the MPP engine, as we like to call it, massively parallel processing engine, harnessing that power of distributed compute. And so if we jump into a little bit more, let's talk about Trino and Spark. So I see one question in the chat that I want to answer about Trino related to Spark. Does it replace it? It really depends on your use case. I have a fantastic resource for you that I'm going to send after this webinar, Musab, which is essentially a webinar talking about ETL for Trino. We have absolutely seen people replace their Spark workloads with Trino. Assurance comes to mind. There's some other options and examples that I have where I've seen people replace Spark completely. There also is a place where, you can have Spark and Trino live in the same environment, but have them specified for different workloads. So there's some great resources that we have. I did a webinar called Transformations with Trino, and it talks a little bit about the differences, and it really has a lot of information between the two. So Anna, I don't know if you're there, if you can link maybe that recording and share that. If not, I will send you an email after giving you all of that information. But really the origin of it is Trino was based as an ad hoc analytics engine. Spark was really based on that, specifically on that heavy compute side. And now as we've seen the innovation with both engines, they're sort of, both of them are traveling towards the middle and you can see the overlap. It's very interesting. But again, like I said, really depends on your use case. But yes, we have seen those replacements. Okay, so what is Trino? Trino is a ludicrously fast open source SQL query engine. They love the ludicrously fast part. Obviously, why not? It's getting you returning data that we had hours to return in seconds. So really awesome. And Trino is created and maintained by a community of contributors, and it's licensed under the Apache license version 2.0. So what that means is that it's open source, it's available for anyone to contribute, and it's based around a community. And that's fantastic because it means that it's a bunch of people that are able to contribute their thoughts and ideas together for the betterment of the query engine, right? Which is what we want. Why is Trino so powerful? Part of that reason is because Trino is based on structured query language, based on a SQL-like language. Okay, I see another question that I think I'm going to jump in and answer. It says, when you say fast, do we have good benchmarking studies conducted under varying query complexity? Fast for simple queries, no difference from Presto on complex ones. We do have some benchmarking talking about the difference between Presto and Trino and talking about specifically the differences between them. I'll send you some resources specifically around that question. So now I'm going to try and do better. I'm going to continue getting through the presentation. If your question doesn't get answered, I will absolutely answer it either post email or anything, but I want to make sure I'll see if I can pop back and forth, but obviously I'm not doing a good job because I want to answer all your questions. So and that's happy. Keep them rolling. I'll just interrupt and jump back. Just bear with me here, as you know, I like the interactive style. I like answering the questions. So keep them coming, and we'll keep rolling as we go. One of the powers of SQL is the fact that you can use this declarative language, right? And we just got a really important question in the chat is, can you use Python? Yes, you can. It's something called PyTrino in Trino and PyStarburst in Starburst. And there's basically some data frames that have been created to help transform and let you utilize basically Python as well in the ecosystem. I'm going to be completely frank with you. It is a data frame which allows you to just transform the Python command into SQL. So there are a lot of other partnership opportunities with IBIS. IBIS and Trino are working closely together. So you could potentially use that to integrate with your Python. So there are opportunities there as well to go beyond just your SQL commands. But it is an area of interest, I know, for our community to go even further with. Absolutely, is to kind of grow that Python community. And so what are the benefits of a query engine? Really, this is just what are the benefits of storage and compute. Really, that's just being the separation of storage and compute means that you can actually connect to the disparate data sources and federate that data. But most importantly, you can scale. You can distribute the power. You can have it as a horizontal scale. You can scale up vertically. You can tailor the query engine to the workloads that you have. They're not intertwined. And then the best part is if you want to change your data where it lives, you can just put the data somewhere else and it's fine. You can still query it with Trino, or you can switch out. You know, it gives you a lot of flexibility and openness and optionality where you can change out based off of what you need going forward. So, you know, kind of like the reason why people love Iceberg because it's multi-engine. Trino, people love Trino because it's multi-data. So you can connect the data from multiple different places. And then when you get those two together, you have a lot of flexibility to really build the best, build what makes sense for you, whether that be a cloud data warehouse, a cloud data lakehouse, build what makes sense depending on your amount of data, your environment, what you're looking for in return. So now I'm going to talk a little bit about how Trino works. We'll dive into it separately, but you can see we have the coordinator, which is the specific brain of the Trino cluster, and that is going to be divvying up all of the workloads. It's going to be figuring out exactly how the Trino optimizer should be running, how the command should be going between all of the different workers. So the worker nodes are essentially just the compute power powering, and they're listening to the coordinator, and they're doing all of the tasks that are assigned to them. Then you have a catalog, which is basically a specific connector for all of your information. So you have a catalog and connector. The connector would be, like a connector to Postgres, right? But then the catalog is a specific information that you would put in to connect to your Postgres catalog. So that's a little bit of the terminology that's going to be utilized as we go through. If you hear anything, stop me if you have any questions. But again, the coordinator is sort of the whole command center brain. The workers do all of the workers, and you can scale up and down as you need. Catalog is the connection to the data source, and the connector is what's written in Trino that you will use to apply to your specific catalog. So let's walk through essentially what will happen with Trino. You'll have a data consumer that submits a query. So you see the end users on the right, they'll just go ahead and submit, in this case, a SQL query. And then basically the coordinator will get that command, and then they'll go through and they'll look at the metadata management, the data authorization, and any identity management to essentially map out the cost-based optimized, the best way to execute that query. From there, the coordinator will assign the tasks to the worker nodes. The worker nodes will go out to each of the data sources and they'll grab the information that they need. And then all of it will get pushed up back to the coordinator. And then the coordinator will deliver it back to the end user. So that was a little simplified, but really just the important parts that you'll need for how Trino works and scales. If there's more questions, throw them my way. I'll send resources for you. And really, the important thing that we want to touch on, I'm absolutely biased because I work for Starburst, and I think that Trino is the best query engine in the world. And why do I think that? Because it's been implemented at scale by a bunch of different industry leaders. So you can see Netflix, LinkedIn, Pinterest, Lyft, Facebook. We've had a ton of people actually be able to share all of this information at a lot of our Trino fests and Trino summits that we have. And it's been so insightful to see Trino actually utilized in the real world. The thing that I also see is that when I was a data engineer, there were times where maintenance was a lot for us, or where we weren't experts, it was a lot. So Trino requires extensive resources to actually be run successfully. So whether you have a small team or you don't necessarily have the Trino expertise, that will add up quickly because you'll have a lot of different components that in the open source aren't really contributed towards, but you need management, security, access control, and support. And that equates to money and time and energy and effort and all the things. Because if you're trying to tune and optimize Trino, that might take away from some of the development work that you're doing on the front end that you're trying to further down in your roadmap that your business users might want. So that's essentially kind of where the trade-off comes, is whether you want to tune Trino yourself or you want to utilize Starburst. But really, it's more than that because there's a bunch, like I said, there's a bunch of things you'll have to think about if you're implementing Trino open source as a query engine that you don't necessarily have to think about as well as if you integrate Starburst, specifically security, access control, and management, which we'll talk about when we talk about building an open data lakehouse. But regardless of what you choose, my goal here is to expose you to Trino so that you can see if that's the right flavor for you. Because whatever flavor you use of Trino, that's still a win for me. Join our community, get involved, learn more. That's what we're trying to do here. So I'm going to talk very quickly about Starburst, a little bit about what Starburst is, why it's better than Trino in certain instances, and when to implement that. So here we have the open data lakehouse. So essentially, this is what we like to call the buildup of what Starburst likes to build within, specifically utilizing Trino. So you can see if we start at the bottom, we have our commodity storage and compute. So this is like our object storage. You can have, Azure S3, any elastic compute you may need. You have your open file formats, which that be Avro, Parquet, and Orc. You have your open table formats, Iceberg, Delta Lake, and Hootie. We really think Iceberg's fantastic here. We're big Iceberg fans. So, and we see really, honestly, it's also the fact that we see a lot of it in the community. So in open source Trino, we have been for years back to 2022 seeing presentations on how people are utilizing Trino and Iceberg together. And then we also say select Trino as your query engine. And then here's really the thing that's special is when you select Trino as your query engine, you can actually access data beyond the lake. You can use the data in the lake sort of as your center of gravity, but then you're able to really build that data lakehouse where you can still pull data in from multiple different sources, which is what we'll do today in the lab. And then, of course, around all of that, you'll need a wrapping of a security, governance, and access control layer. So that is essentially, you will need that no matter what. And that's where Starburst can come in and really help you. So you can build an open data lakehouse without it, just using Trino, but you're going to need something to really build and manage that open data lakehouse platform. And so that's where the security, governance, and access control layer comes in to really help you alongside all of the other benefits that we have of, we have different types of workloads. So we can actually tailor your workload to the compute. We have different offerings of helping you with your optimize your table formats, all the other things, great benefits you'll see when we go throughout the lab today. But this is kind of the picture of, why would you need something like Starburst is to really bring that open data lakehouse platform all together. So I also wanted to just do a quick shout out here. Our CEO, Justin, wrote an article a while ago talking about Icehouse as the open data lakehouse, and it just talks a lot about Trino and Iceberg as the specific, pillars for that open data lakehouse. And I have the link to the blog post in the top, but I wanted to show you some of the open source trusted, we know specifically like logos that are utilizing Trino and Iceberg together, which is huge. So you can see Netflix, Apple, SK Telecom, Stripe, Shopify, all of these people are utilizing Trino and Iceberg together as the, as the foundation for their data platforms. And then you can also see below, we have some managed Icehouse users where people are utilizing Trino and Iceberg. So they're utilizing the Starburst flavor of Trino and utilizing Iceberg to go ahead and build their Icehouse and essentially utilize that, give that warehouse-like experience to the data lake, utilizing those two components. So this is essentially, you may ask me, what are the differentiation between Trino and Starburst? It's this slide. Everything here is all of the things that you can add in addition to Trino utilizing Starburst. So we'll go through and actually share, we'll walk through a lot of them as we're going through the lab today. But, starting at the bottom, we have these data sources where you're able to actually go cross region and cross cloud. You can go on-prem and you can go in the private cloud and a public cloud. And then if we get to data access, you can actually deploy anywhere. We can have streaming ingest. We're trying to push the boundaries here and make it as easy to access your data as possible. And part of that is, also schema discovery, data discovery, all the things that we'll do in the lab today. Then we have security and governance, which is essentially you can have different things like RBAC and ABAC, so role-based access control, attribute-based access control. We'll have lineage, row and column level masking, monitoring and logging, and all of the information that you may need to build out that security and governance layer around that data lakehouse. We also have the query engine, enhanced query engine. It's powered by Trino, but what Starburst has done, and our awesome engineers here, is they've really enhanced the current capabilities that Trino has to accelerate some of the querying within our proprietary query engine. So I want to call out two things here: warp speed and fault tolerant execution. Those are two modes that I'll talk about a little bit more to query your data based off of the workload that you have. But essentially, warp speed will get you, it's a proprietary indexing and caching layer that will get you about 40% faster in the data lake, depending on if you're utilizing it on, S3 or where, I think S3 is where the test was run. But I can get you the information on that too if you have more questions on it. And then we've also done things to help make it even easier to utilize, like cluster auto scaling, dynamic filtering, and then enhanced, stuff like enhanced Parquet reader and fault tolerant execution. And we'll talk through those different types of compute when we go through the lab, because we'll build our cluster together. And then another thing we've done is added that modeling and semantic layer where you can have your catalog, your metastore, all of the data information, and global search, so you can actually go in and, view the data that's connected, so you have the information going forward. And of course, the third-party integrations are standardized, they are secured, they are enterprise grade approved. But a lot of I'm going to be honest with you, a lot of the integrations with visualization tools are also available in Trino, but they're not at that enterprise grade level support. Okay, so for the next part, we're going to talk about our hands-on lab. So I'm going to pop over here, and don't forget that all of the resources will be available to you via email. So if you have any questions or anything, don't worry about it. It'll come your way. So here's the lab we're essentially going to do today. I'm going to talk through a little bit of it. We have our data. We're going to have some Uber data landing in basically S3. We're going to have some geolocation data from NYC new NYC 2015, I believe is the year. And it's landed, and we're going to be looking at the months January through June. And what we're going to do is trying to analyze some patterns for our marketing department because we work at Uber. And we're going to try and figure out essentially where the most common place to get picked up was from specifically the different boroughs and neighborhoods that work in New York City. We have our data from all of the geolocation for the pickups being ingested into S3. And what we're going to do is clean, optimize, and then basically produce this data consume layer that's ready to be utilized by anyone downstream. So our first step is we're going to have the bronze layer, which is just the landed layer. We're going to just get the raw data involved, and we're going to then clean that data up in our silver layer. And then we're going to actually need some data that lives in Snowflake to join that data together to get the insight we need for our marketing team. So serves a couple of purposes. This is showing, our center of gravity for our data will be in the lake, but we're still accessing data that lives outside the lake, pulling in that data from that multiple different sources. And really, it's just, eliminating any sort of ETL job you might need to bring that data then into the lake, but essentially giving it so that you can still continue building out your data pipeline in your data lakehouse. Then we'll do our gold layer, which will actually build a data product for our data science team and our marketing team. So both of our downstream consumers will set up some data products. And this is the best part is we'll add that security, governance, and compliance layer around it so that our end users are ready to just utilize the data that we have in our data lakehouse. We'll also be using Iceberg. Well, after we clean and optimize the data up, we'll see some of the fun things you can do there to really, again, give that warehouse-like capability to the lake. And then we'll be able to sort of, go forward and send the data on the way downstream to the consumers. So that was a little bit of talking. Now we get to do the fun part where we actually get hands-on. And in order to get started, again, go to that lab guide on the docs page. If you're looking to, watch along today, that's totally fine. The passwords will be available until September 4th. And if you have any questions about any of the lab material, go ahead and email me at monica.miller@starburstdata.com. So now I'm going to switch over to Starburst Galaxy. And again, we're going to be using Starburst Galaxy as specifically our, the easiest and fastest way to get up and running with Trino. If you're looking to go ahead and run the lab, I have this just all laid out for you, so you don't have to copy paste from the lab guide. That should be earlier in the chat available to you. If you just scroll up, it says lab gist. So that will also be there, but worst case scenario, let me know and I'll throw it back in the chat. So I have my Starburst Galaxy instance, and what I'm now going to do is get situated so I can look at the lab and the chat together. So let me just go ahead and move that lab guide over. And we are going to rock and roll. So if we get started here, you can see the beginning is sort of the purpose of the lab, our introduction. You can see a little bit more of what I talked about. And then we can also look at creating a Galaxy account. We are going to skip this for now. We're going to go to page 7, actually. That's where we're going to get rolling. But if you wanted to get started or do this lab later, go ahead and click the Galaxy account link, and that will be able to help you out. So we are going to start here by connecting to our 2 different data sources. So you can see here we've got our AWS S3 data source we want to connect to and our Snowflake data source that we want to connect to. So our first part of this lab is going to be connecting to our data sources and creating our catalog creating our cluster that will actually power the connection to the catalogs that we've created. So I'm going to go ahead and get started. And what I'm going to do first is go over to my query editor, and I want to click on the catalogs button that's available right here in the data. So you can see the one catalog I already have connected. You shouldn't have this, don't worry. And then we have all the different sample catalogs available to us that come with, Starburst Galaxy. Now I'm going to hit the Create Catalog button, and we can see we have different object storage connectors. And then we also have all of the additional data sources that we also have available to be connected through the Create Catalog. We can see, some new data sources coming about, all of the different preview available, and we have a lot of work going on to build more connectors within Galaxy as well. So I'm going to click on this Amazon S3 button, and what that's going to do is bring me to the catalog connection page, and I'm going to use the lab guide on page 9 to connect my first catalog to my data lake. So I'm going to type my catalog name of NYC Uber Rights. And if you're going along, go ahead and get the catalog names exactly right, because the queries will reference these catalog names. So go ahead and copy exactly what I have in the lab guide. We also have the description for the specific catalog. This one you don't have to copy verbatim. And then we have our authentication method to S3. So we have two different ways that you can authenticate. You can either use an access key or an IAM account role. We're going to do an access key for today. So I'm going to copy paste what's in the lab guide here available on page 9. Oh, let me try that again. View, that looks right. There we go. Got my space removed. And then now what we're going to do is implement the Metastore configuration that we have available to us. So we're just going to use Starburst Galaxy for today. But if you see, we can have AWS Glue or a Hive Metastore connection if you wanted as well. For our default bucket name, we're going to put Starburst 101 Lab. And for our default directory name, what you want to do is put your name, not my name, but change the your name to what your name actually is. So I'm going to say Monica Miller, and then I'm going to put 101 at the end so that I know that I'm doing this through the 101 Lab. This is so all of us can work in that same bucket, but we've set the permissions in AWS so that none of it will interfere with each other. So that's why we need each one to set a different default directory name. I'm going to hit the allow creating external tables and allow writing to external tables, because we're going to be doing some transformations. And by that, we're going to be, creating and writing. And then we are going to leave the default table format as Iceberg. So I'm going to hit the test connection button. We've got this little green hooray, which means good job. We've got connected to our first catalog, and I'm going to hit that connect catalog button. The next thing we're going to do is we're going to set the permissions for the specific catalog. Essentially, we're just going to hit save access controls here, because what it's doing is assigning permissions to the account admin, which is what we want to do, because we're going to go in later and attach more permissions to specifically the new roles we want to play with. So I'm going to hit the save access controls button for now. Next thing I want to do is hit skip cluster, because on page, so it says on page 11, we are going to build our own cluster later. So I'm going to hit skip. We don't have any cluster to add it to now. And you can now see I have a new catalog with the cloud, the region, all of the information that I just created. I can click on it. I can look in at it, can see what I have. And that is the information for the first catalog we've created to our S3 data lake. Now I'm going to create my second catalog, and this is going to show sort of that federation, accessing data within the lake and beyond the lake. And I'm going to hit that create catalog button. Going to go down to the Snowflake data source, and I'm going to enter the information that's found on page 12 of the lab guide. That's going to give me the catalog name, description, all of the connection information I'll need to pull in that data so that we can run those federated queries, so that we can pull in that data into our data pipeline that we're building within our data lakehouse. So let me go ahead and name it as said. This is going to be our lookup information specifically to grab for, the geolocation data. We're going to need the location information, so the borough and the neighborhood, and that's where we're getting this from, the taxi zone lookup. Then we're going to pull over the description. So this is just, saying exactly what I just said. It's to look up information for NYC. We want to pull over the Snowflake account identifier so that it knows where to connect. We're going to do our Starburst 101 username. And then we are going to insert the password that's on page 12 of the lab guide. This is the password as well as with the AWS access key that will rotate on September 4th. If you need more time or you want another, stab at the lab, go ahead and send me an email. We can do a working session or we can extend the credentials based off of what you need. So now our database name, we're going to enter NYC Rideshare. That's where that data lives. We're going to select this warehouse name that's set up for us, which is Starburst 101. And then we're going to select the Snowflake role that's already set up for us as well, giving us select access to that warehouse. And that role is the Starburst 101 role. So now I'm going to hit that test connection button and we can see that green check. So I'm able to hit that connect catalog button. Same thing as I said earlier for our access controls, we're going to hit save access controls. And now what we're going to do is, again, hit skip on the cluster. So on page 13, we're clicking skip because, again, we're going to build our own cluster that we've customized to the workload that we need. So now if I scroll down on the catalogs that I have available here, we'll see this new taxi zone lookup has popped up. In the same region, conveniently. How funny is that we have the same region as we need? And then we also have, you can see the snowflake icon. We can click in here, look at the schemas, the metrics, the data that we have available. We can look at this table. We can even do potentially a little data preview if we select a cluster, or we can look at the definition, all of the information that we have for that specific data. So obviously we need a cluster. So that's our next step. We're going to move on to page 14 of the lab guide, and we're going to build out our cluster so that we're ready to get the compute power behind to connect to those data sources. So I'm going to hit in the left-hand side, if you can see the navigation, I'm going to go to the admin dropdown, and I'm going to hit the clusters button. And we can see here we have one cluster that's already created for us. We're going to create a second one because I want to show you a little bit about the different ways that you can customize your clusters. So I'm going to hit this create cluster button. And in the lab guide, we're on page 15. What we're going to do is go ahead and look at the cluster name. And we're going to actually add it as NYC Ride Info. Again, this one you want to make sure is the same, because we are going to actually be going forward with, naming some of our queries specifically with this cluster. So go ahead and make that the same. The catalogs, we have two catalogs to select. We have the NYC Uber Ride catalog to select and the Taxi Zone lookup to select. So make sure you select both of those catalogs. And then automatically it will pop up for us to select that US East Ohio region, which is awesome. So the next thing I want to talk about is specifically the different execution modes that you can have within creating a cluster. So today, I want to also make it very clear that as a developer advocate, I want to make everything I do for anyone free. There is a 30-day free trial for Starburst Galaxy for all of these enhanced features like warp speed, like fault-tolerant execution, like bumping up your cluster size. But I run my lab so that anyone, maybe you're on day 31 and you're still evaluating, then you should be able to do the lab as well. So everything that we do will be free in this environment. However, I do think that since we're going to be crunching 12 million rows, we should absolutely bump up our cluster size. But in this scenario, I wanted to really, I want to make it so that everyone has the ability to run these labs. With that being said, if we were in the environment today, I would select accelerated as our query type or fault-tolerant execution for our resource-intensive queries, depending on what my use was. If my use was just to go faster with y'all, then I would absolutely select accelerated, because this is the proprietary indexing and caching layer warp speed, which has all different information to speed up our data lake queries, which you'll see we'll need on one of the transformations we're doing later. And it's not bad, but it's like as a free cluster, we should at least horizontally scale it a little bit. The other option we have is to then select fault tolerant mode, which is essentially just guaranteeing your resource intensive queries. If you have any questions on fault tolerant mode, there's a whole awesome webinar we did, again, talking about transformations with Trino. Talks a little bit about, information Martine had previously talked about at Datanova, their experience with fault tolerant execution at Facebook, and using it with Trino, and all the good things we've added to Starburst from there. And I'll send that in the follow-up as well. So we've got this information for you here, but you can select your different execution modes. So that means that as you're building out these clusters in Galaxy or SEP or whatever you're using, you can actually tailor the cluster specifically to the workload. So if I know I want to run, or I have these analysts running long queries, I want to speed them up, I'm going to get that accelerated query going. I know that I have some engineers building dashboards for our CEO. I'm going to probably put it on fault tolerant execution. So again, that gives you a little bit of an example of the different execution modes you can utilize. We have different free cluster sizings. If you are interested, you just signed up and you're like, oh, let me just push it a little bit further. Go ahead and select a small or medium cluster. Again, I am doing the free version because I want to be there for anyone else doing any sort of free version as well. On the right-hand side, you have the query result caching information here. And then you also have the uptime. I'm going to pump this to 30 minutes. And if you notice, there is a comment here in page 14 and 15 about the idle shutdown time being 5 minutes, but 30 minutes is asked. Go ahead. I apologize for my screen grab. Go ahead and bump it up to 30 minutes so that as we're talking, it's actually idle shutdown time has changed to uptime. As we're talking, we'll be able to, make sure that nothing shuts down if we go through. So go ahead and bump that up at least beyond 5 minutes. Thank you for the awesome call out there, Friedrich. Now going to hit create cluster because I've got all the information I need for my cluster creation. And I'm going to make sure that switches on. And now my cluster is starting. So we're able to get that information that we need. And as it's up and running, we'll have more information here. So in that cluster, one more thing I wanted to mention in there is that's where the auto scaling happens. So if you would have changed your cluster to, I guess I can go in and show you instead of just talking about it. We could actually have changed our cluster size here. You can, different scale based off of what you need. And then we help with auto scaling. We help with graceful shutdown. We help with any sort of, switch over you may need. All the things you wouldn't get with Trino. That's really what Starburst is doing specifically with your clusters. Okay, so now I want to go to page 16 of the lab guide. We've got our cluster up and running, and we're going to build that first layer of our data lakehouse, and that is called our bronze layer. So we're going to be doing the standard medallion architecture. We have our bronze layer, which is just the raw data, our silver layer, which is going to be clean and optimized data, and our gold layer, which is ready for our data consumers. With that, we're going to start with our bronze layer. And so I am going to pop over to to our data catalog that we've already created. So I can go here and click on the catalogs button. And I want to click specifically on this NYC Uber rides catalog. You can see here we have the different schemas. There's no information right now, but we're going to click on the schema discovery button right here. And what we're going to do on page 17, we're going to run schema discovery. So what is schema discovery? Schema discovery is something that essentially helps you examine the metadata of specific object storage location. It's for catalogs that have the object storage location only. So S3, ALDS, GCS, you can grab the information. But really what you do is you use it to identify tables and views that may be in a specific location. This is really handy. I used to be a data engineer and I would have loved this because instead of getting access to the data in S3, which I rarely did, I would have to figure out the information from a wiki. that was very difficult and very hard. And it would have been so much easier to actually run schema discovery and get the information there, as opposed to being able to like look into the file or download the file or even know about it, because that wasn't really maintained for us. So what we're going to do is we're going to click that Run Schema Discovery button, and we're going to copy over the location URI that we want to, that's in question that we want to look at. You can see we have a button that pops up for us. Again, this is about adding that security, governance, and access layer automatically, where we don't have any privileges to access this location. And it's just saying, would you like to add them? Check, and it checks it for us. So we're absolutely just able to add those privileges really easily. And then we're going to leave the default schema as discovered schema, just for ease of use. And then if you look at the advanced settings, we have two different types of discovery. You can do incremental discovery from last run or full discovery. In this case, it doesn't matter because this is our first run, so it'll be a full discovery anyways. But you could also then build out an incremental load as opposed to that full historical load. So just depends on your use and what kind of discovery you want to do as you're going forward. For now, we're going to just click that button for full discovery, but it doesn't matter either way. I'm going to hit that Run Discovery button, and we are going to scan. And you can see here we have discovered a schema and a table within that schema. And that table has 6 different partitions. So I'm going to click the checkbox up here in the left-hand side, selecting all, and I'm going to click the Create Table button. So now you can see we have 3 different commands being executed. We're creating a schema if it doesn't exist. We're creating a table, and then we're syncing the partition metadata, where we're adding the information that we need from that create table statement. Okay, so we are on, I lost my lab guide page. We are on page 19 of the lab guide. And what we're going to do now that we've run schema discovery is go and hit close over here. And we can see it's scheduled, it's running. And the next thing we want to do is actually go and test that schema discovery worked. We want to see what our what our bronze layer looks like, right? For the first time, being able to see it. So I'm going to go navigate to the query editor. And if you see, I can open up the cluster I've created. I've got my 2 different catalogs. We have the S3 catalog, we have our Snowflake catalog, and we can now see this discovered schema with a table in it, which is awesome. That means it picked up something. And so what I'm going to do here is select the cluster, which is the NYC Ride Info cluster. And I'm also going to select the catalog that we have available. So there should be, with schema discovery, there should be data in our bronze layer right here under the discovered schema. What we're going to do is run a basic select to view that data and see if it's copied over. If you didn't get schema discovery to work for you, don't stress. We have an appendix, which has all of the information for specific commands you can run yourself to get that discovered schema available. So you don't actually have to go through schema discovery. Although I encourage you, if you have time, to go ahead and try it again to, see if you can get schema discovery to work. So now I'm going to copy over on page 20 the simple command. Okay, see, this is where the gist comes in handy. Let me pull that guy up and over. I am going to copy over from page 20. We're going to basically run that simple select to see if we got our data in our bronze layer. And it's an external location. So we're just pulling in that data from where we have. And we can see that, as expected, we have a dispatching base, the pickup date, affiliated base number, location ID, and the year and month. And then if we want to run a show create table statement, we'll see kind of what that table looks like that we've created. And we can see here that this matches exactly what was in schema discovery. So we have the create table, we've got all of the different specific data types and columns that we're going to be utilizing. And then if you want to see here, we have the external location we're pointing to. the format CSV, and in here we have a Hive table. So this is the way the data is landed for us. And what we need to do is update that data to Iceberg. So we're going to use Iceberg table formats going forward. And in order to sort of separate that out, we're going to create a new schema so that everything going forward is, Iceberg based. So we'll do that in a minute. So on page 21, you can see we just want to verify the schema in the catalog, which I've already done. We want to make sure that we've got the data that's available for us so that we can basically build our silver layer. You can see it here. And this is where I mentioned that if you couldn't get schema discovery to work, go ahead and refer to the appendix in the lab guide. That will show you the commands for what you need to get up and running so you can build your silver layer. Okay, so now we're moving on to lab 3, which is really the fun part. This is about really diving into building that data lakehouse, that medallion architecture. So we've got our bronze layer established in this discovered schema. We've got our silver layer, which we're going to establish, which is our clean, optimized, data, enriched, transformed, whatever word you want to say. And then we'll have that gold layer that's ready for our end consumers. Okay, so we're going to, now that we've validated the bronze layer, I want to run one more query to kind of validate, which just shows that we got all of the partitions that we needed potentially from our, that live in S3. So on page 23, I'm going to run the command that is basically saying select the distinct year or month from our discovered table. So essentially, we're just pulling out the fact that we really want to make sure we have all of the different months that we need, because we're going to look at January through June, which we do. We have all of the different partitions, all of the different months. We are good to go. This is just a little small data quality check that we can do. We are now going to start on page 24 of the lab guide. So we have gone through page 23 where we've created our bronze layer, and now we're going to start on page 24. So on page 24, the first thing we're going to do is create our schema. So if you don't have this NYC ride info selected up here, make sure you select that. If you don't have your catalog selected, so this is your cluster, this is your catalog, make sure you have these two selected, as you can see here. Now we're going to be building a schema within that we can then select so that all of our queries run smoothly for everyone. So on page 24 of the lab guide, you can see step 2, which says create schema. And what we're going to do is copy over that command. And I am going to create the schema. Oops, my copy is not working today. We can see the command. It says create schema with our catalog. And what you need to do is delete your name and put in an identifier for yourself. I'm going to do Monica Miller because it's my go-to, but put in some sort of identifier that you have that you know that this is you. It can really be anything this time, whatever you want. Just identify something here with, what you've created for your schema. I am going to hit the run button here, create that new schema. This is where I'm going to put all of my Iceberg tables and views. And we can see that we now want to kind of validate that schema in the catalog. So we've got a green finished. I'm going to refresh here. And we can now see I have a new schema with no content in it. This is great. The next thing we want to do is select the schema we just created up here in the top left, because this way all of the queries that we're running within the lab guide are just going to automatically execute. So I'm going to click select schema and collect Monica Miller. How did I force the refresh? I went and clicked on the NYC ride info and it loaded again for me. So if you can either click on the S3 information or click on the cluster. And then as far as going here, so we're on page 25 of the lab guide. You can see we wanted to select that schema after creation. So I have my cluster selected, my catalog selected, and then my identifier schema selected as available. And now we get to the fun part. We get to really run some SQL commands. We get to build that data lakehouse. We get to do some transformations. We get to build that silver layer. And so what we're going to do is first copy over on page 26 that create table statement, where we're going to essentially grab the information that we need from our discovered schema and build out a new table. So I'm going to go to page 26 of the lab guide, and I'm going to copy that create table statement. You can see here we have our create table with all of the different fields that we want. We've identified them specifically with the with the data type of choice. And you can see here we're building with type iceberg and format parquet. If we deleted this row, we'd be fine because we have iceberg as our default. But I like to call it out in these queries so that we can essentially really showcase exactly what we have. Okay, I have a question in the chat. If the schema got changed in source, does Starburst detect such change? Say one new field is added. Yes, it does. We will be able to show you column level lineage and table lineage later in the lab, but you'll be able to see there is the transformation difference where it will be able to show you for it. I have a really awesome PM I can introduce you to who's probably doing more research on this. But essentially, we are looking into identifying those the upstream and downstream changes, and we have some now with our lineage tools that we already have in place. Okay, so we've now created our our second table in our first table in the silver layer, our second table overall. And the next thing we want to do is actually insert rows into that table. So we're going to be doing some pretty heavy duty transformations. If you go to page 26, I am going to run this command and then explain it. So what we've got here is we are inserting into our table, our new table that we just created. We're going to cast the pickup date as a timestamp. We're going to cast the location ID as an int, and we're going to be inserting it specifically from the year month table. So we're going to still be pulling the partition as year month. We're going to be using the new table format as iceberg, the new file format as parquet. And the whole goal we're going to have here is to really, we're crunching those numbers to make it so that our data is set up for success where we want down the line. This is going slower than you may seem. We're crunching 12 million rows. It's going to be about 40 seconds, 45 maybe. And essentially, what we're doing here is a very heavy duty transformation on a free cluster, which I wouldn't recommend. I'm doing it to show you because I hate examples that use 100 rows and don't matter. So I thought it'd be really fun to play with some real data. If you've got that 30-day free trial, I'd be really interested if you ran the lab with a small or an Excel. Actually, I know with an Excel, it's going to be about, 5 or 6 seconds. So that's just showing you we're literally using one node right now in our Trino cluster. So, which is the coordinator and the worker node. So don't fear if you're like, why is that time so long? I promise it's just because I would rather actually do some data that makes sense versus just kind of giving you a fluff example. So we've inserted the data on page 26. And the next thing we're going to do is kind of validate that silver table. So if we look and just run a basic select, we'll see something very similar to what we saw before. But if we actually describe the table or we do another show create table statement, we'll actually see, the different information than what we had before. So I can go in here and I can click show create table, and we'll see that it looks different than what we had in the bronze because we can see the format as parquet, the iceberg versioning, the location now in our different, this is our default as set in our catalog. And then this is our schema that we've created. And this is our table with our ID from iceberg. Okay. On to page 27. What I want to show you is some of the information that we have for, selecting from the iceberg tables we have available, except I see there's a question in the chat. First time I ran the query, it took 16 seconds for 1,000 rows. Ran it second time, then it took less than a second. Can you explain this? Yes, this is the proprietary indexing and caching that we have available to us. So if you remember back in the cluster cluster settings that we had, we left the default of query cache on for 5 minutes. So what that means is it's pulling the cache results for you there. That's why it only took the 0.55 seconds. Okay, so now we're going to look at the iceberg commands in here. Really, I just want to show the snapshots and the partitions, dive into why iceberg's so cool, and really just, we have, if you're looking for more iceberg resources, go ahead and check out the awesome hands-on iceberg lab that's linked in the lab guide. Or if you have any questions about it, email me. I'd love to dive into iceberg stuff with you. We have a lot of awesome resources for it. Okay, so you can see here we've got our 2 snapshots showing the creation of the table, and then showing the append, which actually shows all of the different records that we had inserted, all of the information we have available. And then if we actually look at the partitions, we're going to skip the history command for now. If we look at the partitions, we'll be able to see we have all 6 partitions, all of the different rows we have in each. And we specified this partition in our table, if you remember. If not, it would partition it based off of what, the manifest files thought. So we've got our record count, our file count, total size based off of our partitions. Okay, so the next step we're going to do, this is what we're going to actually show our federation. So we're expanding beyond the data lake here. We're going to run one SQL query on page 27 to federate the data between the data lake specifically and with our Snowflake taxi zone lookup information. So again, we have a reference table, a lookup table. We're pulling the information from both. And you can see here we have all of the information. Anything with a P prefix is actually being pulled in from S3. Anything with an L is being pulled up from Snowflake. I did the P. I can't remember why I did the P, but ride pickup or something. And then the L is for location for lookup. I have feedback for myself already when I was rerunning this lab this morning to change that, so it's a little bit more clear. But I'm going to hit that run button. So what we're going to show here is one select statement that's able to pull the data in from 2 different locations, which is awesome. So if we go look at our results here, we'll see the dispatching base, pickup date, lookup location ID, all from S3. And then our borough and our zone ready to roll from the Snowflake table. This is really impactful for anyone that potentially has, analysts where you don't want to move an ETL, you don't want to move a table over just for them to be able to query 2 tables together. You don't want to make another data pipeline. You can just help them set up a role for them in Starburst and have them do ad hoc analytics there. I just wanted to show that power before we actually jump in and run our next create table. So our third table, which is building out our consume layer, or our gold layer. Sorry, consume and gold's similar depending on, same meaning. We are going to move on to that page 28 where we're actually building out that gold layer. So we're going to be enhancing this query that we just ran to actually build the table. So I'm going to copy over the query from page 28. We're going to derive, this is our final columns deriving. The reason we had to derive it this way was because we were cleaning and optimizing our data in the silver layer to get it to a timestamp so we could derive. And then we also have, again, an iceberg table with the format as Parquet doing that join on both of these different data sources. So I'm going to hit run, and we're going to get our final gold table so that we're able to go ahead and build out for our data consumers. This is what we'll base the 2 views that we're going to create on for our data products. And then I like to joke here, especially on really interactive sections, that this is where I've built this in with this many rows because I need a sip of water here because I'm just fun to talk, but sometimes I get too excited. So now we have created our second run. Again, 12 million rows we're doing transformations on. We're doing a join. And we can see that we are going to have a new table. So if I go ahead and run on page 28, that basic select statement. Shoot. Here we go. I have to copy from the gist because it doesn't like me if I don't. Okay, running that select statement, you can see here some of the changes. Oh, this is the wrong command. Rides by zone is what we want. Ride pickups is what we just saw. So here we go. Finally, rides by zone. We're doing a brief of the table, the consume, the goal table we just created. We can see we have all of the information from our S3, all of the information. These are our two derived columns that we built from the timestamp. And then we have our two uh, lookup information from the borough and the zone. All of it in one table. Really fast, really awesome. And now we're going to run some basic interactive analytics. So we're going to just run a select statement that we have on page 29 of the lab guide, and we're going to examine. So the goal is we have some teammates in our marketing team that are like, well, what's the most popular borough by which day? Looking at this historical data, we want to see if we want to, maybe get more people in the unpopular boroughs to sign up. So we'll run a promotion. All of it. We're going to hit that run statement and we're going to do some evaluation. So we've created this with statement to kind of aggregate those results and view what we have. So we have each of the different boroughs, the most popular weekday, and the total number of rides available. Now what we want to do is kind of harden that into a view so that it's available for them as we can build out with our access control so that they can see that data at any time. And it will just be, we can build a data pipeline with our favorite orchestration tool with like Airflow, Dagster, Prefect. And then you can basically have it incrementally load each night. And then they'll have the information already established for them. Every day that they're curious, they can go look. So on page 30, we're going to copy over the create or replace statement, which is the same command as the with statement we just ran on page 29, but we're adding the specific, delete, let me copy here. We're adding the specific command at the top, which says create or replace view. So we're creating a view to get the most popular weekday. Hit that run table command. And we've got it created. So now I'm going to select from the table. And we can see exactly what we had before. Now our marketing team said we did such a fantastic job. They want a different level of granularity for the same analysis. So we're actually going to create the most popular month view as well. So I'm going to copy over the command on page 31. And we're going to segment it by months. It's the same command, except instead of segmenting and partitioning by, weekday, we're going to partition by month. So I'm going to run that command. And then we'll look at what we have as our results. So on 31, page 31, I'm now just going to select from that most popular view that we created. And here we'll see the total analysis by month for each of our different boroughs as well, with the total number of rides. So that's basically building out that data transformation pipeline. And now what we're going to do is kind of finish up that consume layer or that gold layer by securing access to it. So we're going to make sure that only the right people have access to the data, our marketing team to the views, our data scientists to our bronze layer where they can play around and do some discovery from what they want to do. So I'm going to actually navigate on page 32 to the access layer or the access navigation, and I'm going to click on the roles and privileges tab here. So I'm going to click on that, and you can see we have two roles available. The account admin is where we should have been doing all of our work, just because that's the easiest thing to do. It's got all the permissions we have. And now we're going to create another role, which is our data science role. So I'm going to hit the add role button, and I'm going to copy over on page 32 that I want to create a data science role. And I'm going to add a description where this role specifically for the data team that's trying to grant access to view for the purpose of building and training models, right? Oops. Copy that over. And I want to grant this to the creating role so that we can flip back and forth and we can evaluate the role. I'm going to hit add role. And then I'm going to create a second role on page 33 where I'm going to hit the add role button again. And I'm going to create a marketing role. And this role is specifically designed for that marketing department where we're granting access to the aggregated views. And I'm going to hit that grant again button so that I'm able to go ahead and look at the information. I'm going to hit add role. And now we can see we have two roles that we've created, two roles that came standard in Galaxy. And now we're able to really build out a comprehensive role-based access control system, even just really simply. And then the really powerful part is when you start combining attribute-based access control based off of a tagging system with your role-based access control, you can get extremely granular as to what data is allowed for each person. Okay, so now we're going to assign the privileges that we need to each role. So on page 34, what we're going to do is actually click on the data science role. So I'm going to select this role right here, click on it, and I'm going to navigate to that privileges tab. And in the privileges tab, you can see there's already some privileges based off of where we've assigned. I want to hit the add privilege tab again, and I want to specifically modify the privileges for the location for our discovered schema. We want to make sure that we click in, like I just didn't do, but we want to click into this discovered schema and we want to click on that year month table. And what we want to do is give this data science team access for selecting from the table. So it's got the specific scope of NYC Uber rides, discovered schema, year, month. And I'm going to hit save privileges. And now I'm going to navigate out of the data science role. There's a back button here. I'm going to hit that. And I'm going to click on the marketing role and click within it so I can assign those privileges. So on page 35, you'll see on the marketing team, we have the different privileges we want to assign, clicking on the privileges tab, navigating to the add privilege section and going for the scope that I want, which is again within the NYC Uber rides data lake, but it's a different schema entirely. It's going to be in the schema that I created, the Monica Miller schema. And if you can see here, it will replace with whatever you specified as your schema. But I want the NYC Uber rides most popular month. And I'm going to, again, this replaces with whatever you said. I'm going to allow access, the select access only. And then I'm going to click, don't hit save privileges yet, but it's okay if you do. But don't yet, because what we're going to do is we're going to add a different scope. So we're going to pop open again and click on the second view that we have available. And I want to select privilege from there as well. And you'll notice that when you select it, it goes away. So don't freak out, if it moves back and forth. So like I'll select, it goes popped over. You'll want two green selects over in the left hand or on the right hand side, which will give you access to each view. So you should have save privileges with a little 2 by it, and we should be good to go. So I'm going to hit save. And now you can see I have different catalog privileges within the NYC Uber rides than I would in the marketing team, as opposed to if I was in the account admin role or the data science role. I encourage you, if you have questions about that, email me or we'll explore them on your own. This will all be set up after so you can look more into it. And now what we want to do is on page 36, we're going to test our roles. So I'm going to navigate to the account admin role switcher in the top right corner. You see up here, it says account admin. I hope you can see that. I am going to actually navigate to the marketing role. And you can see here a little bit of a different view because they don't have access to anything. So we've got the welcome for the marketing team. I now want to go to that query editor as a marketing person. And if you look here, you can see that you have the Monica Miller with or my specific schema with only the 2 views that I have available. Yes, as a user, you can be a part of multiple roles. We're actually going to demonstrate that here because you'll be a part of the marketing team, you'll be a part of the account admin team and the data science team as you test out all of these roles together. So what we want to do to test the roles, and what if there are conflicting privileges? It depends on the role that you are assigned in the top right. So only account admins can switch back and forth. that have the ability. If you are not an account admin, you won't be able to. So, you can assign based off of granularity. If there are conflicting privileges, we actually specifically depends on if you're account admin or not, but we'll default to giving the privilege for more. But we can help you set up the privileges so that you get the level of granularity you need. Okay, so what we want to do on page 36 and page 37 is, we can see only the two tables we have available. We want to run a basic select from the borough most popular view. User will log in with one role. Yes. So, but okay, so I am a user. I'm going to take a little detour here because I think it's important. And then we'll go back to page 36. So I am a user. I'm an account admin. I logged in with my account admin role. Absolutely. Which gives me the privileges to be able to go ahead and switch between all of the different admins that I have. If I were to, say demonstrate, go to the roles and privileges, give, I think in the public role, you could have, or I don't know, maybe if we were to go back to the marketing team, we could assign a user. Let's say I wanted to assign Richard as specifically just a marketing role. Then he will, anytime he logs in at all, he will only be able to access that marketing role. Again, because I have logged in with the account admin user, I have the ability to look into more, as should you, based off of the fact that you created Galaxy today. Okay, so that thank you for letting me take that detour. I'm gonna go here, and what I want to do is navigate back to my marketing role to match where you're at. And I'm able to see in my schema I created with two different views that I can select from the table. So I'm gonna hit on page 37. I'm gonna hit the button to hit run. And I can see the view. But if I were to actually go up and select this create table, let's see what happens. And it fails. And that's because the user does not have any privileges to create on the table. They only have specific select access, which is really important. And so now what I want to do is actually show the data science role. So we've got our specific marketing role shown of what they're able to access. Let's go up to the top right and navigate to that data science role. And you'll see it'll again look differently, where they're only able to see the discovered schema with that one discovered table. And we are going to run from try accessing the exact same view that we just did. So we're going to click that select button. And we'll see an access denied, relations not found. It's not specified for that user. And if we run specifically from the select from the discovered schema table, command on page 37, we'll see that we are able to access it. We get all the information back. But if, let's say we want to try deleting from that table, and if we hit that run button, we're not allowed because we don't have access. The only user for the data science team only has select access to the specific table. So now, really, really, really important here, navigate back to the account admin role in the top right before proceeding. Our final lab, we're going to create some data products. These are going to be for our end consumers. We are going to do this by going into the global search button up in the top right here, clicking on that little magnifying glass and typing the word borough. This will pull back, and when we click view all results, pull back all of the different places that borough may exist. And we're going to narrow that search by you can see all the different options. I'm going to only select on the asset type as a view. And then what I'm going to do is select on the most popular weekday view. So I'm just going to click on it. And you can see we have the information on the location, we have the description, the owner, and I'm going to hit that open details button. We can actually navigate and see the lineage of the different table for all of the different, information that we had. So you can click on the show columns, and then you can even click on the show column lineage. And then if we kind of scroll in here, it's a little bit hard to see, but it's really impactful because you can actually go and look at all of the different column level lineage that you had available. So someone was asking what happens if a column changes. We'll track it here in our specific, in our lineage tab. But it's really cool where you can click on the different information for each of the lineage and kind of go forward from there. There's more questions. Of course, I'll get you in touch with Rio. He's fantastic. Okay, so I'm going to make that smaller again. So we've got the lineage information here. We can also do quality checks for all of the data as you're going through and building out your data pipelines. Again, a data preview. And if we go to the privileges tab here, you can see in the account admin role, we can see that marketing select allow, the account admin allow, all the information you might need for each specific role. So what we want to do is on page 41, we want to, now that I've played around a lot with the view, we want to navigate to the schema in the top left that you've created. It will be different for everyone. I'm going to click Monica Miller, and I want to fill out the details to promote my data product. So I'm going to enter the information on page 41. And I'm going to go a little bit faster just to make sure I finish this lab for everyone. So if you get lost, go ahead and, catch up on recording. So I'm going to copy over the description. You can add a tag. I'm going to add a link that I have, which is to specifically display the data source information. And I can copy over that link. And then I can also assign myself as a contact so that everyone knows who to bother if something happens. And then I can actually promote that to a data product. So I'm going to hit promote to data product button, import all of the descriptions we just put in, and I'm going to put my data product name right here where I'm going to add specifically that this is, our data product for our Uber Rides team. So I'm just going to copy this over. And I'm going to say it's the aggregate data product. And I am going to click through the information that I need. I want to add a basic description just saying that this is like what we're using it for. Our data product approach, copy that in from page 43 in the lab guide. I'm going to select my default cluster and I'm going to promote to the data product, which is awesome. So one thing that I want, in case you have to drop off, one thing I want to show you is kind of the different ability to look at a data product through the lens of multiple different roles and access controls. So I have the account admin. I can look at the data scientist who have no access to it because we haven't granted them any access for that data product. And then the same thing with that marketing team actually does have access because they were able to, with the way that we set up the role, to view the data product. So I'm now going to go, and that is because if we look at the schema specifically, the data scientists don't have access to the schema where we put all our iceberg tables. That's why they couldn't see it. The discovered schema lives in a different schema, and that's why they don't have the ability to see the data product, whereas the marketing team does. And they can go in there and they can actually go view the data, they can query the data, they can look at all the information. And then you can have data products that get really complex too. You can share with other domains. You can click on the summary. You can look at the different data model, the data set, how to use it. You can look at the different tables and views in question, the materialized views, the owners, and all the information you may need. We're trying to build out that metadata around all the data that lives within your data product. Okay, so another little detour, but I'm now going to go back to my data product screen. And what I want to do is create a data product for the data scientist really quick. So I'm going to go to my catalogs, because that's the easiest way. And I'm going to grab my NYC Uber Rides data, click on that discovered schema, and I'm going to hit promote to data product. And I'm going to name it as the NYC Uber Rides, but I'm going to name it as that bronze layer only. I'm just going to say test for now, test because we're moving fast. Select my default cluster. There's a supporting information link in the lab guide, and I'm going to just keep moving for now, add a different contact, which is also me, but you know, it is what it is. And then I'm going to show you here where we can look at those different screens, look at the different information, and you can utilize access control alongside your data products to really give that fine level of granularity. There's also a video I have, I think, linked in the specific on page 50, which has all the information for data products, but basically just going through and showing you if we have the data science team, they have the specific bronze layer. We have the marketing team, they'll be able to see the aggregate layer, but then we've created all those different data products, which we have available to be seen by whoever. And then if we look into the specific data product, you'll be able to see a different view if you're the account admin, where we can see all of the information, or if you specifically, I want to look at the aggregate, account admin has access to the tables and the views. If we switch to that marketing role, we'll only have access to those two views. That was a lot of information. If you have any questions, please throw them in the chat. I'll answer as much as I can in the very, very minute we have remaining. If not, I will do everything that I can to follow up with an email with all the information. So I see one that says, does it support parameterized views? To be honest, I'm not exactly sure what you mean by parameterized, but we do have both materialized views and just regular views that you would have. So thank you so much for joining me. Throw all your questions in the chat and we'll fill them out as we go. It was really fun. And don't forget to sign up for Data Nova. It's going to be really awesome, October 23rd and 24th. Please go ahead and join us. If you like this, you'll love Data Nova. So have a great day, everyone. Great to chat. I'll stay here and pull those questions and you'll see an email from me.